So today what we're going to be looking at is more of the chain rule, but today we're going to also need to factor out a common factor. So looking at from last year and from Math 2, okay, looking at this problem, factoring out the GCF, okay, 3x to the fourth plus 5x cubed minus 7x. Of all these three terms, we can factor out this x. So we factor that x out, and what we'd be left with is 3x to the third power plus 5x to the second power, or 5x squared, and then just minus 7. And really, technically, this is x to the 0 power. And I'm doing that for a reason, because we got to figure out like what's going on. Like, how do we get these exponents? And what we're doing is we're taking this exponent and subtracting out the exponent that we pulled out. So there's an exponent of 1 right here. So this 3, we have to understand where this 3 comes from. This comes from 4 minus 1, because this has a power of 1 right here. Where did this power of 2 come from? Well, it came from the power of 3 that we started with, and we took 1 out. So 3 minus 1. And where did the 0 come from? Okay, why are we writing that? Okay, now, really, we would just write minus 7, so I want you to know that. Okay, but when we factor this 1 out, we started with a power of 1, so that's 0 because we had 1, power of 1, and we took 1 out, so 1 minus 1. That's where the 0 comes from. So we're also going to have to look at groups of things. So like this problem, 3 times the quantity x plus 5 to the fourth plus 5 times the quantity x plus 5 cubed minus 7 times the quantity x plus 5. So they all have an x plus 5 in common, and we're going to factor out the smallest power of it. So that'd be to the first power. So this is going to become x plus 5 raised to the first power, but we're not going to write that, and then times what's left. And actually, let me use a bracket instead of a parenthesis here. Okay. And what we've taken 1 out of this one, right? So now we have 3 times x plus 5, but we no longer have it to the fourth. We actually have it to the third power. Why? Because we took 1 of these out. And then plus 5 times x plus 5 to the second power, because we had 3, but we had to remove 1 of them, right? So that's why we have a 2. And then minus 7 and x plus 5 to the 0, right? Because we had 1 and we pulled it out. All right, so this came from, again, this one came from 4 minus 1. This one came from 3 minus 1. And we're not writing 1 because we had 1 and we took 1 away, right? So that would be the 0, x plus 5 to the 0 power, just like up here. All right, let's take that one step further, okay? And what's going to be important is, which of these do we factor out? And if you look at this, it was the smallest power, right? It was the smallest power that we factored out. Okay, let's look at the next two problems. So for this problem, 3x raised to the 5/2 power plus 5x to the 3/2 power minus 7x to the 1/2 power, there is a GCF here. And what it is, it's x to a power, but the GCF is going to be, of all of these three powers, it's the smallest one. That's the one we're going to factor out. So in this case, it's x to the 1/2 power. So we're going to factor out an x to the 1/2 power, because that's the smallest one, and then times, and then this is going to become 3x, and we had 5/2, but we have to remove 1/2. So this is going to be 4/2, and then plus 5x. Well, we had 3/2, right? But we're going to take 1/2 away from it, so that makes 2/2. And then minus, and then we factor that x to the 1/2 out, so minus 7. All right. Now, where did this 4/2 come from? Well, we started with 5/2, and we're removing the power that we factored out, the 1/2, and that's where the 4/2 comes from. And we had 3/2, and we took out the power we factored out, which is 1/2, and that's how we get the 2/2 here. So I wouldn't want you to leave it like this, okay? This cleaned up would be x to the 1/2 times, and this would be 3x squared plus, and this would be just x to the first, so plus 5x, and then minus 7. All right, so we're from the power we started with, we're going to subtract the power that we factored out. It's going to be important, okay? This next one, 3x to the 4th plus 5x cubed minus 7x to the negative 2 power. All right, which of these powers is the smallest? And it's the negative 2 power. So that's the one we're going to factor out. Now this is going to take on a weird thing, okay? So we're going to factor out this x to the negative 2 because that's the smallest power of x. All right, so now nothing changes, all right, because we're still doing everything the same way. We're going to take this power and we're going to remove, we're going to subtract the power that we factored out. So this becomes 3x, and I'm going to write it out this time. We started with a power of 4, and we're going to remove the power that we factored out, so negative 2. And then plus 5x to the 3rd, but we're removing negative 2, so minus negative 2 power. And then minus 7, and then x, and we had negative 2, and we're going to remove negative 2. And that's what we're doing. Now, I'd like you to do this in your head, but I'm okay if you need to write it out, okay? So this is x to the negative 2. This is actually becomes 4 plus 2. So this is 3x to the 6. So what actually happened is our powers got bigger, right? Because we were removing a negative power, which actually becomes addition here, okay? And then here, this one's going to become plus 5x to the 5th power. And this is going to be minus 7x to the 0. X to the 0 is 1, so that's just minus 7. So this is how you factor out a GCF. You find the common one, and you pull out, or you factor out, the one with the smallest power, okay? And then what happens is the powers that you had, you need to remove or subtract that power that we factored out, okay? We really didn't factor out a power, so it's kind of a misnomer right there. But we're factoring out x to that smallest power, okay? All right, let's go do some problems now. All right, so we should recognize f of x is equal to x squared times the square root of 1 minus x squared, and we want to find the derivative of this, okay? So we need first rewrite this. So this is f of x is equal to x squared, and instead of square root, we're going to write this as a 1/2 power. So 1 minus x squared to the 1/2 power. So this is the first function, and this is the second function. And so we're multiplying two functions. We have to use the product rule. We got to use the product rule on this, okay? Now, here's the other thing. This second function right here, all right, is actually a composite function. So we are going to need to use the chain rule to find the derivative of this one. This is where it starts to get a little bit difficult, okay? All right, so you just gotta be careful. You gotta write, don't skip steps. Don't skip steps because it's easy to miss something, all right? All right, here we go. Okay, so f prime of x is equal to, so I'm gonna take the derivative of x squared because that's my first function, and the derivative of x squared is 2x times this second function left alone. So that would be 1 minus x squared to the 1/2 power, and then plus, and then it's going to be this first function, so x squared, times, all right, now we got to take the derivative of this second function, but to take the derivative of this second function, we have to apply the chain rule. So we're going to bring the power down, so 1/2 times 1 minus x squared, because that's the inside part, that stays the same. And now we got to remove 1 from this power, so 1/2 minus 2/2 makes negative 1/2. All right, and now, okay, so we took, that's the derivative of the outside function. Now we need to take the derivative of this inside function. The derivative of 1 is 0, so really we just need to take the derivative of negative x squared, which is negative 2x. Okay, so now f prime of x is equal to, again, this is 2x. We're going to clean this up a little bit. So 2x times 1 minus x squared to the positive 1/2. We can multiply this one, and this one together. I can't multiply this one because it has a power to it, and then we'd be violating the order of operation rules, okay? So right here, and I'm going to change this because this is positive and this is negative. So it's actually going to become minus. And we have a 1/2 times 2, which is going to be 1, and x squared times x, which is x cubed. So this is going to be x cubed. And then 1 minus x squared to the negative 1/2. All right, we're not done, okay? So we're not done yet. All right, so now the next step in all of this is we need to look for a GCF. And there's actually 2 GCFs here, okay? One of them is that and we got to look at it, as this is one term and this is another term. And so what do these 2 terms have in common? And that's what separates it right here, is the subtraction, okay? So what these have in common is they both have an x in common, and they both have 1 minus x squared raised to a power, so they have that in common. And so what we're going to factor out is the smallest power of x, which is x, and the smallest power of 1 minus x squared, which is 1 minus x squared to the negative 1/2. Okay, so this is going to equal x times, and again, the common factor would be 1 minus x squared raised to the smallest power of that, which is be this negative 1/2. And now I'm going to put a bracket in here. Okay, so we pulled out this x, so that's there. So we had a 2. We had 1/2, but we're going to remove negative 1/2. So this is 2 times 1 minus x squared. And we started with 1/2. And we're going to remove the smallest power, which is negative 1/2. And then minus. And all of that got factored out, right? If you wrote negative 1/2 minus negative 1/2, you wouldn't be wrong, okay? But what's left here is x squared. Heck, I'm going to go ahead and do it, okay? So this is going to be 1 minus x squared. We started with negative 1/2, and we're subtracting negative 1/2. And then I'm going to close my bracket. All right, so I'm going to clean this up a little bit. So this is x times 1 minus x squared to the negative 1/2. And this becomes 2 times, and 1/2 plus 1/2 is actually 2/2, which is 1. This becomes a power of 1, so it becomes simpler, right? So this is just 1 minus x squared to the first power, but we don't normally write first power, we just leave it alone. And this one becomes minus x squared, and this is 1 minus x squared raised to the, and this becomes 0, so we don't even need to write that one. And so that's what we have left, okay? Now we can clean this up, because if I distribute the 2, I'm gonna be able to combine like terms. So now this is x times 1 minus x squared to the negative 1/2. And I'm going to change, because I'm going to distribute the 2 in here, I'm going to change the bracket to parentheses. And this becomes 2 minus 2x squared minus x squared. And then we can combine this minus 2x squared with a minus x squared. That it's going to make minus 3x squared. So this is equal to x times 1 minus x squared to the negative 1/2 power times 2 minus 3x squared. Now, the only thing left is I really need you to write this without negative exponents. So this one right here is going to become 1 over 1 minus x squared to the 1/2 power. So I'm going to slide this up a little bit. So this is equal to x times 1 over 1 minus x squared to the positive 1/2, and then times this quantity 2 minus 3x squared. So the final answer would be x times 2 minus 3x squared all over 1 minus x squared to the 1/2 power. And that would be your final answer to this problem. Whew, right? Woo! Long ways, huh? These are gonna take a little bit of time, okay? All right, so that's the answer. So really that's it. We combined the product rule along with the chain rule, and we factored out a GCF, and the GCF always is the same base, but with the smallest power, okay? So they have to have a common base, but we factor it out with the smallest, the one we factor out is always with the smallest power, okay? All right, let's go to the next problem. So for this next problem, f of x is x over the cube root of x squared plus 4. So even before we even try to do this, we need to rewrite this. Okay, so there's going to be I'm going to tell you about a couple ways we can do this, and I'm going to choose one way to do this, all right? So f of x is equal to x over, and then cube root becomes x squared plus 4 raised to the 1/3 power. Okay, so what we could do is, and I'm going to zoom in a little bit here. Okay, so what we could do here is we could apply the quotient rule because this is a quotient. Now, you could also rewrite this another way and write this as x times x squared plus 4 to the negative 1/3 power. And so you could apply if you wrote it this way, you could apply the product rule. Now, I'm going to tell you, I think probably for this problem, the product rule is going to be a little bit easier, but it all depends. Sometimes the quotient rule is the one that's going to be easier. So for this problem, since I already did one that was the product rule, I'm going to choose to use the quotient rule on this one. But again, if you chose yourself to do the product rule, I'm fine with that, okay? The only time I would say you have to use a quotient rule is when I say use the quotient rule, okay? All right, so here we go. So if I apply the quotient rule to this, f prime of x is equal to the derivative of the top, so that would be that would be 1 times the denominator, which would be x squared plus 4 raised to the 1/3 power, and then minus the top function, which is x. And now we got to multiply by the derivative of the denominator. And in order to do that, this is a composition of two functions. So we're going to have to apply the chain rule to this. So this would be times 1/3, because I got to bring that power down, and then times x squared plus 4. And then I got to subtract 3/3 from this because that's 1, and that becomes negative 2/3. And then we still got that's just the derivative of this outside function. And now I got to take the derivative of the inside function, which would be 2x. So times 2x, and then all over this denominator, okay? So that'd be x squared plus 4 raised to the 1/3, and then I need to square that. Okay, so this is part of the problem that makes this a little bit more difficult in that using the quotient rule is that you wind up with these fractions, okay? So this wouldn't be so bad if that was a whole number, but it's not, it's a fraction, okay? I'm still gonna do the quotient rule, okay? So 1 times this is still just this, okay? And so f prime of x is still equal to this x squared plus 4 raised to the 1/3 power. And now what we'd have is minus, and this would be 2x squared over 3. And then times x squared plus 4 to the negative 2/3 power, all over. And then to simplify this, okay, we have something raised to a power and raising it to another power. We need to multiply these. So 1/3 times 2 becomes 2/3. So this is x squared plus 4 raised to the 2/3 power. Okay. Now the very next thing is you should be seeing there's a GCF here. And the GCF is this x squared plus 4. So this one's being raised to the 1/3 and this one's being raised to the negative 2/3. So which one do we factor out? Well, we're going to factor out the smallest one, the smallest power. So that's going to be the negative 2/3. Okay, so I'm going to come off to the side here. So factoring the GCF out, this becomes x squared plus 4 raised to the negative 2/3 power. And then I'm going to have a bracket. And then this one's going to be x squared plus 4 raised to the 1/3 because that's what it was. But now I got to subtract negative 2/3. So this would be x squared plus 4 raised to the 1/3 minus negative 2/3 power. And then minus 2/3 x squared. Because that whole part got factored out. And then all over this x squared plus 4 raised to the 2/3 power. Okay, so we still got to clean this up. Okay, so now this, you may have already realized this is 1/3 plus 2/3. This is 3/3. So this is just a power of 1, right? Okay, so then that makes f prime of x equal to x squared plus 4 raised to the negative 2/3 power. And this is just x, this is just going to become x squared plus 4. And then minus the 2/3 x squared. All over this x squared plus 4 raised to the 2/3. Okay, so now I'm multiplying this by this. So I could rewrite this whole thing as this one right here times this fraction, with where this is the numerator and then this is the denominator. And that's what I'm going to do next, okay? Because I kind of want to get this by itself, okay? Plus, if you look, these are going to be the same, right? Okay, so I should put equals here. Equals, this is going to be x squared plus 4 raised to the negative 2/3 power, then the multiplication. And then this would be x squared plus 4 minus 2/3 x squared all over x squared plus 4 to the 2/3 power. Now what we can do is we can rewrite this one as 1 over x squared plus 4 to the 2/3 power. And we're almost home, guys. We're almost done. And this, so this is 1 over x squared plus 4 to the 2/3 power, and then times, and then x squared plus 4 minus 2/3 x squared all over, and then x squared plus 4 raised to the 2/3 power. Okay, so 1 times this is just going to be this top, right? So this becomes x squared plus 4 minus 2/3 x squared all over. Okay, so if I'm multiplying and the bases are the same, I'm just going to add these exponents. So 2/3 and 2/3 makes 4/3. So this denominator becomes x squared plus 4 raised to the 4/3 power. Okay, so the last problem we got to deal with, because there's a lot of problems that we're dealing with here. Okay, the last thing we got to deal with is we can't leave it like this because we have a complex fraction. We have a denominator in this numerator. So how do we deal with that? Well, one way is we can multiply by 3 over 3 to get rid of that denominator. So that's what I'm going to do. I'm going to multiply by 3 over 3. And that means this 3 I'm going to have to distribute with each of these. So we wind up, let me slide it up a little bit, with f prime of x equal to, this would be 3x squared. And 3 times 4 is 12. And minus, and then 2/3 x squared times 3, well, that'd be minus 2x squared. All over, and then this would be just 3 times this. So 3 times x squared plus 4 raised to the 4/3 power. Again, you can't bring the 3 in because you'd have to do the power before you multiply by the 3, and we can't do the power. So we can combine some like terms up here in the numerator. All right, so this is going to be my final answer. So f prime of x winds up being just x squared plus 12 over 3 times x squared plus 4 raised to the 4/3 power. And that's the final answer, okay? All right, so if you had chosen to do the product rule, you're still going to have to deal with some negative exponents, some negative fractional exponents. But you'd wind up with the same exact thing, okay? If you did everything right, you would wind up with the same answer if you take your answer and make sure you write it without any negative exponents, okay? All right, so that's just about the hardest one I could give you, okay? That's hard because you're gonna wind up, especially if you have fractional exponents, you're gonna wind up, when you bring that power down, you're gonna wind up with fractions if you use the quotient rule, okay? All right, guys, let's go to the next problem. So guys, these are all the derivatives of the trig functions that we learned last time, okay? But, all right, with the exception of, this is with the chain rule, okay? So the derivative of sine of u is cosine u times, and then we'd have to take the derivative of du with respect to x. So u prime is du over dx also, okay? So this is just the derivative of this inside function. And so they're the same derivatives of the trig functions, but you're always going to be multiplying by u prime. All right. Okay. So for this first example, if y equals cosine of 3x squared, find dy over dx. Okay. So we've got a composition, right? Because we have this inside piece. So dy over dx is equal to, so the derivative of cosine is negative sine of the 3x squared. Okay, so that's the derivative of the outside function. Now I got to multiply by the derivative of the inside function. So the derivative of 3x squared would be 6x. Okay, now to make this really clear, probably the best way to write this is negative 6x sine of 3x squared. Okay, so that's probably the best way to write it. So if y equals cosine of 3 times x squared, find dy over dx. Now, this is not 3x squared, this is just cosine of 3. And we have to realize that when it's just a trig function or a square root or anything else that's with just a number like this, that's a constant. So this is really a constant, okay, times x squared. So it's equivalent to saying y equals 5x squared or y equals pi times x squared. This is just a constant, okay? So when we go to find dy over dx, okay, so it's a constant times x squared. This is just a constant times the power rule. So this winds up being equal to cosine of 3, because that's our constant, times 2x. All right, and I would say it'd probably be better if we wrote dy over dx and wrote it like this, 2x cosine of the number 3. Okay, I think that's just a little bit easier for people to read because a lot of times you look at this and you think, oh, am I multiplying the 3 by 2x or the cosine of 3 by 2x? And it's really, you got to pay attention to the parentheses a lot more. Okay, let's go to the next one. So I hope you're realizing that all of these are just cosine with a 3, with an x, and with a square somewhere. And the parentheses where you place them changes the problem, okay? So for this one, okay, the very outside function is cosine. Inside that, we have the squaring function. And inside the squaring function, we have 3x. So this is one of those where we have a function within another function, all right? So dy over dx is equal to, okay, so the derivative of just the outermost outside function, which is cosine. So that's going to be negative sine of 3x raised to the second power times, okay, so the next outside function after you do the outermost is the squaring function. So that's going to be 2 times 3x raised to the first, right? I'm gonna put a 1. And if you didn't put a 1, that'd be okay. All right, and then times, and now we got to take the derivative of that innermost function, which is 3x. So times 3. Okay, so this we can actually multiply 2, 3x, and 3. All right, so that'd be 18x multiplying by this negative. So dy over dx is equal to negative 18x sine of 3x squared. And that would be the answer to this problem. Okay? So for this next problem, we have to find y equals cosine squared x. Well, really, that is rewriting that. That's really cosine of x just squared. Okay, so the outside function is the squaring function, and inside that is the cosine function. So dy over dx would equal, the power comes down, so 2 times the same base, which is cosine x, raised to the first power. Okay, and that's just taking the derivative of the outside function, which is the squaring function. And now I need to take the derivative of the inside function, which is cosine of x. And then derivative of cosine x is negative sine x. Okay, and so now we can clean this up a little bit. And so dy over dx is equal to negative 2 cosine of x sine of x. And that's our answer to part D. And that's how you do composition with trig functions, okay? Just a little bit more. I know we did a little bit yesterday, but this is just a little bit more. Now for this last problem, it's y is equal to 3x minus 1 over x squared plus 3, and then take that quotient and raising it to the second power. All right, so here we go, all right? This is, the inside function is a quotient. So when we go to take the derivative of the inside function, we're gonna have to use the quotient rule. No way around it, we gotta use the quotient rule, okay? And the outside function is the squaring function, right? Okay, so what we should see at first is just the derivative of the squaring function, and then we're gonna need to multiply that by the quotient function, okay? Or the quotient rule, all right? So here we go. Dy over dx is equal to, so bring this power down, so 2 times 3x minus 1 over x squared plus 3. And in previous years, on this next test for this unit, I've asked a problem like this, okay, for you to do. Okay, so what you're looking at is just the derivative of the squaring function. So now I got to take the derivative of the inside, and the inside is a quotient, so I'm going to have to use the quotient rule. So times, and then the derivative of this top, which would just be 3, times the bottom, which is x squared plus 3, minus the top, which is 3x minus 1, times the derivative of the bottom, and the derivative of this bottom would be 2x, all over x squared plus 3 squared. Okay, so cleaning this up a little bit, this dy over dx is equal to 2 times, and really this is just 3x minus 1 over x squared plus 3 times, and then multiplying this out, this would be 3x squared plus 9. And this would be 2x times 3x would be 6x squared, but I need to subtract it, so that'd be negative 6x squared. And 2x times negative 1 is negative 2x, but I need to subtract it, so that becomes positive 2x. All over, and then the denominator is x squared plus 3 squared. Now really right here, if you look at this, this is the same base, right? So we're not writing it because this has a power of 1. So you could put parentheses around this and raise it to a power of 1, because then you see that, okay, I just need to add these exponents, okay? So what this becomes is dy over dx is equal to 2 times 3x, 2 times the quantity 3x minus 1 times this, and this would be negative 3x squared plus the 2x plus the 9. Now, if you're a little bit of a different order, but the signs were right, you'd be fine. All over, and this is x squared plus 3 to the first times x squared plus 3 to the second, so that makes x squared plus 3 to the third power, okay? And then we'd want to, if we could, all right, and I don't believe you can, is you'd want to try to factor this if you can, because we want these in factored form, okay? You can't, so we don't even need to try, all right? And that's the answer to this problem. I mean, it's not one of the harder ones we've done today, right? Probably that one that we did with the quotient rule was probably the hardest, okay? Well, with the quotient rule and the chain rule, all right? Okay, so that's all of that. I think that's the last problem. Oh, no, I lied. Okay. All right, so this is the last problem, okay? All right, so we got to realize what's the outside function here. And this is one of the ones that I think is the most difficult to see, all right? Because what does it mean? Because it doesn't look on the outside, right? But actually this cubing function right here is on the outside, because what that means is sine of 4t times sine of 4t times sine of 4t, or sine of 4t, all of that raised to the third power. So we are going to rewrite this. So f of t is equal to parentheses sine of 4t, and we're raising it to the third power. That's what this 3 means. It means this, okay? So now you can see the outside function is the cubing function. Inside that would be the sine function, and then inside that is this 4t function. So once again, this is a function within a function within a function, okay? So the derivative f prime of t would be the derivative of this power function. So this would be 3 times sine of 4t squared, and then times, okay, so the next inside function would be the sine, so that'd be cosine of 4t, and then times the derivative of this inside function, which would be 4. Okay, so we have 3 times 4 times cosine 4t, so that'd be 12 cosine of 4t. So we could write this as f prime of t is equal to 12 cosine of 4t. And then we'd write this as sine squared of 4t, because we're taking it back to this way of writing it, okay? Because this and this mean the same thing, all right? And that's the derivative of sine cubed of 4t, okay? All right, that's it, guys, for today, okay? All right.